Now let us derive some important expressions taking the Bohr's postulates into consideration. Okay. Deriving different expressions. You know, in an atom, electron okay, let's just draw the nucleus first. Right. Then now, you know, the nucleus is positively charged. This is the nucleus consisting of protons and neutrons. And you know, electrons revolve around the nucleus in specified circular orbits of fixed radius. Okay. Electrons revolve around the nucleus in specified circular paths of the fixed radius. Now, during this, two things happen. The first one is the positively charged protons present in the nucleus. We know that nucleus consists of protons and neutrons. Okay. Now the protons present in the nucleus attract electrons towards themselves. Okay. This is called electrostatic force of attraction, right? It is because it is operated between positive and negative charges. It is also known as Coulombic force. Okay. Now this Coulombic force can be given as minus kz E square by R square. Okay. You can also call it centripetal force. You know, this force attracts electron towards the nucleus. But you know, electron tries to move away from the attraction of the nucleus. In order to move away from the attraction of the nucleus, you know, it operates a centrifugal force. This particular force is generated due to the revolutions of electrons. So centripetal force and centrifugal force, they are, of course, operated in opposite direction. So is this negative charge. They are operated opposite to one another. You know, these two are equal in magnitude, opposite in direction. That is the reason why electron does not fall into the nucleus. The forces are balanced. Okay. Now, taking this point into consideration, let us derive some important formulae. Okay. Now, see, the centripetal force is minus kz e square by r square. That is equal to centrifugal force, nothing but minus mv square by r. Okay. You know, this k here can be given as 1 by 4 pi epsilon naught, where this epsilon naught is the permittivity of free space. It's called permittivity. Permittivity, and the value of this can be given as 8.854 into 10 power minus 12 farad per meter. Farad per meter. Okay. Now coming to the value of K. You know, in CGS, the value of K is just 1 dyne per, dyne centimeter square per ESU square. Whereas in SI system, it can be given as 9 into 10 power 9 Newton meter square per coulomb square. Okay. So in CGS it is 1. You can just neglect. Whereas in SI it is 9 into 10 power 9 Newton meter square per coulomb square. So two important things. One is epsilon naught, the other one is okay, K. Now again, come back to the original. You can just cancel out these two, and even R can be cancelled. So what do you get? R is equal to R can be written as kz e square by or else we will write, okay, one more step. Simply you just write it as kz e square by r is equal to mv square. Now let us take the same old expression of angular momentum. Let this be equation 1. Okay. We know that angular momentum of electron revolving around the nucleus, MVR, can be given as NH by 2 pi. So what is V here? It can be written as NH by 2 pi MR, taking M and R onto this side. Let this be equation 2. Now we got the expression for V. We can substitute it here. Okay. Let us substitute this, I mean 2 in 1. What do we get? M into, now V square is N square H square by 2 square pi square M square R square. That is equal to K Z E square by R. Is this okay? Now look at this. This is your V square. Now cancel out the similar terms. R get cancelled. That's it. That is the only thing. One more, of course, this M. Isn't it? Now let us write the expression for this R. So from this, the final expression for radius of the nth orbit can be written as N square H square by 4 pi square. You still got one M, 4 pi square M K Z E square. So this is the expression for radius of nth orbit. That is very important. Look at the expression carefully. Let me just put it aside. Right? So that is the expression for radius of nth orbit. Now looking at this, it is very clear. The radius of nth orbit is directly proportional to n square, inversely proportional to z. Okay. So that we will be writing in the next step. Let me write. Now come on, let me write the expression once again. Radius of nth orbit is equal to n square H square by 4 pi square M K Z E square. A very important expression. Now, leaving behind the n square and z, substituting the values of H, Planck's constant, pi, a constant, M, the mass of electron, K. Of course, you know that it is 9 into 10 power 9 in SI system, or in CGS it is 1. And of course, E, nothing but the charge on electron. Substituting all these values, you know, you can just write this as 0.529 into n square by z angstrom in angstrom, or else, you know, radius of nth orbit can be written as 0.529 into 10 power minus 8 into n square by z centimeters. Isn't it? Because 1 angstrom is equal to 10 power minus 8 centimeters. So this, of course, is in CGS system, right? Now radius of nth orbit can be written as 0.529 into 10 power minus 10 into n square by z meters. So this is in SI system. Okay. Now, leaving behind the constant value, I mean this one, we can even write it as Rn is directly proportional to n square, inversely proportional to z. Means as the value of n increases, I mean the principal quantum number increases, radius of nth orbit increases, right? With increase in n, radius of nth orbit increases. Similarly, with increase in z, radius of nth orbit decreases. Right? So in the first case, they are directly proportional, whereas in the second case, they are inversely proportional. Right? So that is all about the radius of the orbit. Okay. You need to remember all the things. You have to be careful about this course, this especially. Right? Next. Let us go for some other relation. Coming to different types of energy. Energy of electron. Okay. You know, total energy of electron in nth orbit can be given as the sum of kinetic energy of the electron in nth orbit and of course the potential energy of electron in nth orbit. So let me give you that the kinetic energy of electron in nth orbit is half kz e square by r. Okay. Then coming to potential energy of electron in nth orbit, this can be given as minus k z e square by r. Okay, check this out. These are the potential and kinetic energy. Now take the sum of these two. You will get the expression for total energy of electron in nth orbit. So this is plus half and here it is minus 1. So this would be minus half because it is minus 1 plus half. Finally, we get it as minus half. Of course, the remaining thing as it is minus half kz e square by n. This is the expression for total energy of electron in nth orbit. So this is very important. Of course, even these two are very important. These expressions are very important. Right? Now let us substitute r in this expression. Come on, let us write the expression for total energy of electron. So coming to total energy of electron, let us just substitute the thing. In nth orbit can be given as minus half kz e square by radius of nth orbit. So this can be given as minus half into kz e square by, we know that radius of nth orbit from the previous derivation we have n square h square by, of course divided by, but goes into numerator, n square h square by 4 pi square m k z e square. Now check out. Right? Everything except that has to be retained. Coming to the expression for total energy of electron in nth orbit. Come on, minus 2 pi square m k into k square z square z into z, then e power 4 by n square h square. So this is the expression for the total energy of electron in nth orbit. Now the interesting part is energy is negative. Of course, we'll discuss about this. But before that, let me tell you things like, say, keeping Z and N as constant. I mean, keeping Z and N as it is and substituting the other constant. Let us see what do we get. Now let me again take the expression for total energy. What is total energy of electron in nth orbit? That is equal to minus 2 pi square m k square z square e to the power 4 by n square h square. Substituting the values of what? Pi, m, k, e, and h, except z and n. You know, we get the total energy of electron in nth orbit as minus 2.176 into 10 power minus 11 into, of course, z square by n square. This is in erg per atom, right? Now this is in CGS system. Take everything in CGS system, you'll get the final value as this. Now the same thing can be written as minus 2.176 into 10 power minus 18 z square by n square joule per atom. So this is in SI system. Now this is equal to minus 13.6 into z square by n square electron volt per atom. Right. Now this can also be written as minus 313.6 into z square by n square kilocalories per mole. Then minus 1312 into z square by n square kilojoule per mole. So in different units, this is how you can calculate total energy of electron. You know, I can give you some other relations also if you want. Look at the relation. Here there is joule, here there is erg. Now, what is the relation between joule and erg? 1 joule is equal to 10 power 7 erg. Now, there is this electron volt. You know, 1 electron volt is equal to 1.602 into 10 power minus 12 erg, or the same thing multiplied by 10 power minus 19 joules. You know, there is of course, kilo is 10 power 3, but there is something called calories. 1 calorie is equal to 4.184 joules. So these are the different things that you need to know in order to convert the things. Now you can convert things from one another. Okay. Now this is where I would actually like to tell you why is energy of electron negative. You know, when the electron is far away from the nucleus, let me show you. When it is far away from the nucleus, I mean when it is at a rest, Let me just take it this way. Let me first put, okay. So this is the nucleus. Now when electron is at infinite distance from the nucleus, is taken to be zero. I mean, when it is at a rest or at infinite distance from the nucleus, its energy is zero because no force is operated on it. But see, as the electron approaches the nucleus, as it approaches the nucleus, it goes on losing energy. It is already zero. Now it is going on losing energy. So what happens? I mean, it goes on becoming negative and negative, goes on losing energy. So its energy becomes negative. Already zero. And when it goes on losing energy, its energy becomes negative. Now, energy is maximum negative at, in the first orbit. That is the least it can come down, right? When it is far away from the nucleus, its energy is taken to be zero. But as it approaches the nucleus, since it goes on losing energy, anyway, it's already zero. It goes on becoming negative and negative. Finally becomes maximum negative in the first orbit. Maximum negative, nothing but least. Least energy in the first orbit. Okay, so that is how we can explain the negative energy of electron. Okay. And now let us go for the other types of energies like kinetic energy, potential energy, and some other varieties. Now let us take kinetic energy of electron. I told you that kinetic energy of electron is nothing but half k z e square by r, or else kinetic energy of electron in nth orbit can be given as half into kz e square by radius of nth orbit. Now substituting, looking at this, it is very clear that kinetic energy is the same as total energy but with the positive side, isn't it? It is the same as total energy but with positive side, because total energy, of course, the expression carries a negative charge here, right? That is the only difference. Now come on, let us substitute this. What is Rn? n square h square by 4 pi square m k z e square. So this can be written as, come on, cancel out these two. 2 pi square m k square z square e to the power 4 by n square h square. Right? That is the expression for kinetic energy. Now, even here also, you can see that the kinetic energy of electron in the nth orbit is directly proportional to z square, inversely proportional to n square. Let me also tell you about total energy at this juncture. Coming to total energy of electron in nth orbit, we know that, of course, it is the same as kinetic energy, but with the negative sign, right? So that becomes minus z square by n square. Okay, so total energy of electron in nth orbit can be given as minus z square by n square. Only thing is, in kinetic energy expression, there is no minus sign, whereas in total energy, you got minus. Let me tell you the difference. In this case, as the n value increases, kinetic energy decreases, right? But here, as the n value increases, no doubt the total energy decreases, but that decrease will be with minus sign. So decrease in minus sign is nothing but increase in the value. You need to be little cautious. See the difference. As the value of n increases, kinetic energy is decreased. Here, as the value of n is increasing, total energy is increasing because there is minus sign, right? So that's very important. Okay. Now, let us consider potential energy. Now, potential energy of electron in nth orbit, we know that it is minus kz a square by r. Let us take it as Rn. Minus k z a square by radius of nth orbit, n square h square by 4 pi square m k z e square. Right. Now, let us write the final expression. This can be written as minus 4 pi square m k square z square e to the power 4 by n square h square. Now, looking at this, it is very clear that the potential energy is double to the top or twice to the top total energy of electron. Now, even here also it is very clear. Come on. Potential energy of electron in nth orbit is directly proportional to minus z square by n square. So even here also I can tell you that with increase in the value of n, of course, potential energy decreases, but that is with the negative sign. That means the value increases. Right? So with increase in the value of n, you know, total energy and potential energies increase, whereas kinetic energy decreases. That is interesting. Okay. Next. Now let us go for ionization energy. A different type of energy. What do you mean by ionization energy? It is the minimum amount of energy required to remove an electron from the ground state of an atom. Of course, neutral, gaseous, isolated atom. Now, it is the minimum amount of energy to completely remove an electron, means to take the electron to infinite state from the ground state. Okay. Now let me just write ground state is first energy level, right? Now from ground state, you have to take that to the infinite level. That means you have to completely remove the electron from the atom. Now let us consider E2 minus E1. Total energy of electron in the higher orbit minus the total energy of electron in the lower orbit. Come on, we know that the energy expression can be given as minus 2 pi square m k square z square e to the power 4 by, because this is E2, let me write this as N2 square h square. Only difference is, see here I have taken N2 because it is for E2. Now go for E1, keep a minus sign, minus of minus 2 pi square m k square z square e to the power 4 by n1 square h square. Isn't it? Because this is for E1, I have taken n1. Now the second thing becomes positive because it is minus into minus. Come on, let us take the minus into minus plus thing first. I mean, let me consider 2 pi square m k square z square e to the power 4 by, of course, h square into 1 by n1 square minus 1 by n2 square. The first thing is positive and the second thing is negative. Now, let us substitute the things. We know that n1 is equal to 1, n2 is equal to infinite. Now, this whole thing becomes 0 because 1 by infinite is 0. Now, what is the thing left out? See, when an electron is completely removed from an atom, that becomes infinite. Now, let this be the ionization energy of electron in nth orbit. Is nothing but this E2 minus E1. Now, final expression for ionization energy of electron in nth orbit can be given as 2 pi square m k square z square e to the power 4 by h square. Of course, you got this n1 square. So let me write that also. Only difference that you see is here you got n1 square and here there is no minus sign. When you compare this with the total energy expression. So ionization energy is nothing but the total energy of electron in the ground state or the orbit in which it is present or the orbit from where you are removing it, but with the positive sign. Okay, so that's very interesting. Now, if you want, you can give the same thing in terms of potential also. Instead of the energy required to remove an electron, if suppose we consider the potential difference that must be applied is called ionization potential. Okay, in terms of potential also it can be given. Now then we go for say excitation energy, different types of energy. We know that excitation is taking it from ground state to any other state of the atom. That is called excited state, excitation. Now, what is excitation energy? You know, it is the energy required to move an electron from the ground state of the atom to any other state. State of the atom. So from ground state to any other state of the atom. If you want to take the electron, then what is the energy that is required? And if suppose the same thing is expressed in terms of potential, we call it excitation potential. Now let us say what is binding energy or separation energy. Okay. See, it is nothing but, you know, the electrons are bound to orbits wherever they are present. They'll possess the energy of the same orbit. Suppose if something is presented in the first orbit, it will have the same energy as that of the energy of the first orbit. If it is present in the third one, yes, its energy will be the same as the energy of the third orbit. Okay, if suppose it is there in the third orbit and if it has to be removed from there to n is equal to infinite state, I mean, if you want to remove it from the third state completely out of the atom, then that is what we call binding energy. So separating it from the binding of an orbit, right? Now let me say that it is the energy required to move an electron from any state. If it is in first orbit, first, second, second. Any state to n is equal to infinite, means complete removal. Because it is bound to this state. Now you are taking it to infinite state. Is known as binding energy. Okay. So these are the different types of energies that we have. Now let us go for the expression for velocity of electron. Okay. Let us write the angular momentum expression once again. You know, angular momentum mvr is equal to n into h by 2 pi. Okay. Now let me write this as b is equal to nh by 2 pi mr, or let it be like vn is equal to nh by 2 pi mrn. Velocity of electron in nth orbit is vn, and this is the radius of nth orbit, right? Now let us simply substitute this Rn here. We know that the expression is, come on, Vn is equal to NH by 2 pi m R n. Rn can be written as n square h square by 4 pi square m k z e square. Right? So 2 2s are pi get cancelled. M gets cancelled. N is gone. H is gone. So what is the thing left? Bn is equal to 2 pi k z e square by nh. Okay, so this is the expression for velocity of electron in nth orbit. Now, even here also, substituting things other than the z and the n. Let us see what we get. Now the expression is velocity of electron in nth orbit is equal to 2 pi k z e square by nh. Substituting the values of pi, k, e, and h, we get velocity of electron in nth orbit is equal to 2.188 into 10 power 8 into z by n centimeter per second. Now the same thing can be written as 2.188 into 10 power 6 into z by n meter per second. This is in CGS system and this is in SI system. Okay. Now, from the same expression, I can give you that the velocity of electron in nth orbit is of course directly proportional to z and inversely proportional to n. Right. So, as the n value increases, velocity of electron revolving in that particular orbit decreases. Right. Next. Now let us go for expression for orbital frequency, also known as revolutions per second in nth orbit. RPS, revolutions per second in nth orbit. You know, revolutions per second in nth orbit can be given as velocity of electron in nth orbit by circumference of the orbit. Circumference of the circle, 2 pi r. Right. So here you got velocity and here, of course, you got radius of nth orbit. Now substituting all the things, we can get the expression for revolutions per second in nth orbit. Come on, let us substitute. Velocity of electron in nth orbit can be given as 2 pi k z e square by nh. Of course, you got 2 pi here in the denominator. Now, radius of nth orbit can be given as n square h square by 4 pi square m k z e square. Right. Now, come on. Cancel out the things, 2 pi, 2 pi. That's it. So the final expression for revolutions per second in nth orbit can be given as 4 pi square m k square z square e to the power 4 by n cube h. Now from this it can be written as revolutions per second in nth orbit is directly proportional to z square by n cube. Or else, let me first give you the final expression which we get on substituting all the values. So this can be written as 6.58 into 10 power 15, leaving behind this as z square and n cube. This is what we get. Now let me write that into z square by n cube revolutions per second. This is per second, right? So this is the final expression. These two are very important. This is about orbital frequency or revolutions per second in nth orbit. Now, the time period of revolution. We know that time period is nothing but 1 by frequency. Let me take 1 by orbital frequency or revolutions per second in nth orbit. Okay. Or this can be written as a 2 pi Rn by Vn, right? Now, time period in nth orbit is equal to, what do you mean by time period? Time taken to complete one revolution. So that can be given as 2 pi. What is Rn? N square h square by 4 pi square m k z e square. And then what is Vn? 2 pi k z e square by nh. Exactly opposite, reciprocal. So come on, time period of revolution in nth orbit. What do you get? N cube h cube by 4 pi square m k square z square e to the power 4. Now just leaving the n and z, substituting all other values. What do we get? Time period in nth orbit can be given as 1.5 into 10 power minus 16 n cube by z square. These many seconds. So this is time period of revolution. Okay. Then one last. That is angular velocity or angular frequency. You know, this can be given as omega in nth orbit, nothing but angular frequency in nth orbit. This can be given as Vn by Rn. Simple. Substitute the things. What is Vn? 2 pi k z e square by nh. Then what is radius of nth orbit? N square h square by 4 pi square m k z e square. Nice. Nothing goes off. So angular frequency or angular velocity in nth orbit can be given as 8 pi cube, right? M k square z square e to the power 4 by n cube h cube. Now this on simplification will give us 4.126, substituting all the values except n and z. We get 4.126 into 10 power 16 into z square by n cube, again per second. Okay, so this is angular velocity. In all the expressions, you need to know the relation between that particular parameter and the number of orbits, that particular parameter and the atomic number. You need to know the relation between all these parameters. Okay, these are the important formulae that were actually derived on the basis of Bohr's atomic model.